You can just work on that worksheet. The third part of that worksheet, the one with tangent, cotangent, secant, and cosecant, that's due on Friday. You have a couple days to work on it because it does take time. I know that. You have 9 problems. It takes almost forever to get them done. You guys had a pretty good jump on it yesterday. My goal is to do about 10 minutes worth of notes to intro the next section. It's one of the last remaining 2. And then we'll be taking a test probably at some point, maybe either the late next week or the week after, like the middle of the week, like Tuesday or Wednesday of the week after that. It's just, I don't know the time frame that we need to review, okay? This unit we're in is really small. It's based on graphing. All right, are we good to go? Does everyone understand that?
Do you have a knife?
No.
I need to cut the top part of my boot off because it is just raw.
I got scissors, but no. All right. Okay, we ready? All right, if you need graph paper, go to the back and grab some. For those who are at home, I'll send you an email link to some graph paper or a picture of it, and you can print it off on your own. Okay, so here we go. So for this, here's what we have to talk about today. This section is section 1.6. It's one of the last few sections we have. We're going to be graphing rational functions. Rational functions. Now, we've talked about graphing functions before. That was on your first test. You know, where the tails go, where the X-intercepts, Y-intercepts are. This just takes it one extra step, where now we can start mixing in a bunch of stuff together. Okay, so on these types of problems, the big part that's going to be crucial for this stuff is that, do you know how to factor correctly? If you cannot factor, this could be rough. Okay? That's what we need to make sure of. Okay? All right. So let's walk through a basic example. I want to do probably about 2 of these today, and then walk you through the basic rules. And we're going to do a bunch tomorrow, and so that at some point we can get our last, activity for the week. I said activity, probably not a major book assignment where I give you a little slip of paper. We try some on paper. Okay, then you turn it in. But rational functions, you have to be able to factor. I'm just going to give you an example of what I'm talking about here. Okay, so let's say this is 3x squared plus 8x plus 4. And it's all over, let's say this is all over
7. 4. 1, 3, 9.
Actually, let's make this a 7 in the middle. I don't want to make it 8. Let's make that a 7. I want this to actually be able to factor. And let's go with x squared minus 16. Okay, so let's say that this is my problem. Okay, it's a function of some type, and it is rational. Rational meaning a fraction. Now, what I would do first is I would try to see what this idea would happen if we were to factor this thing apart. Okay, the top and bottom. The reason why, when we do this type of stuff, there's a couple different rules you have to consider. Number 1, we need to figure out if there's any X-intercepts. Okay, we need to figure out if there's any Y-intercepts. We need to figure out if there's any asymptotes, vertical or horizontal, because there definitely could be. And that's the stuff we need to figure out. Okay? Questions on what we're about to do. And again, I'm only going to do about 2 of these today. Just a light introduction. I try to pick something somewhat easy, hopefully. All right. So to factor this thing apart, top and bottom, what's the rule for factoring on the top?
Sure.
What's the rule?
Common
Factor.
Well, yeah, but what type? Not common. There's 5 types. We have common, trinomial, difference of squares, cube. Trinomial. So trinomial rule.
How do we know?
It's 2 parentheses. It is a trinomial. There's 3 items.
Oh, yeah,
So-
that would make sense.
Yeah. All right. So now, the rule for trinomial. You look at the back symbol. It's a plus. That means the operations here and here are going to be the same. That's what a plus sign means. They're going to be the same. What you do is you look at the one in the front, and that's what they are. They are both plus signs. So if this was a minus sign, it'd be both negatives. Because they're the same, they're both negatives, if that was a negative sign. If it's a minus sign in the back, it means they're not the same. They're automatically different, plus minus. Question?
So if I have like a 90 in here right now, and I do all the homework on time and everything, and then I get like a 95 on the next test, will I have an A?
I don't know. That's a lot of work that I have to calculate.
I think
How about-
probably.
How about we just focus on this? Probably. All right. Now, focus on this. So,
Just be
Question.
happy with the C or above.
what was that?
Oh, I didn't say anything.
Oh, that's weird. Is it like in a glare?
Who's all lucky?
Here. I wonder if I can just
Did you
pick this
say
up and
that
go
it's hard to see
closer.
the board?
Here.
Is that a branch?
Because like,
Yeah, I could probably scoot it closer. I just don't want to mess up with that camera.
Just
Is
put
that
it
better?
to the desk.
Just have Jake hold it.
Oh, yeah.
Put it on like a GoPro.
Put it right here.
Put it on your forehead.
He just needed to be closer. There was a weird glare. All right. So now, so here's the idea. So now that we factor the top, we have a parenthesis, we have plus and a plus sign, and now what we have to do is break up the 3x squared evenly. So to break up 3x squared, it's probably 3x and 1x.
Yep,
It's
and
lucky
4
you're
1.
left-handed,
Okay.
honestly.
What?
4 1.
It's lucky you're left-handed.
Yeah. Yeah, true.
4 1.
Then the 4, I'm gonna go 4 and 1.
Dude, we could set this other camera up off the ground and move the desk.
It's true. All right.
It's
sit right
2
here.
seconds.
Now, let's talk about. Now, let's-
You want to do it?
Yeah, you want to put the computer
All right.
the other direction, you'll have another foot of room.
Need me to hold something?
Okay, here we go. All right. So, okay. All right.
Hard work.
Now, hey. Okay, so we factor the top. Now, just to check if this is correct, you could FOIL first, outer, inner, last, and see if it gives you 7. It will give you 7. It'll be 3x squared, 3, 4, and a 4. Okay, so now the bottom is a difference of squares. Because they are perfect squares being subtracted, has to be subtraction, so it's going to be x plus 4 and x minus 4. Okay, so now. For
It's
what?
gonna be negative. What did I say?
I don't know.
So if it was a plus 16, it'd be
All right.
x plus 4 to the 7.
No, so if this was a plus, you couldn't factor it. A difference of squares only works for negative signs. If it was a cube rule, then we could try to go with the cube rule.
Wait a minute. What about the 7 in the middle of there?
Because the 7's made from 3x and a 4x when you FOIL.
Oh, crap.
Yeah. Okay.
What a legend.
So now, okay.
I don't know how
All right. Hey, so the next part here. So we factored this thing up. So the next thing that we're going to look for is the intercepts. The X-Intercepts. The X-Intercepts is what makes the top equal 0. So we are looking at the numerator. You're looking at the numerator, not the denominator. And you're trying to figure out what makes both of those numbers 0. So on the top, we have 2 parentheses. We need to figure out what makes 3x plus 4 equals 0. And what makes x plus 1 equals 0. Those are the things in the numerator. So yeah, so one of the answers for x would be negative 4/3 if you solve for x. Right? Subtract the 4 divided by 3. And the other one would be just a negative 1. These are my X-intercepts. That's where I'm gonna hit.
Wait,
Negative
why is x
4
plus 1
thirds
equal 0?
and negative 1.
So then the bottom's the y or what?
And then the bottom would be your vertical asymptotes. So that's the 2 parts. That's why we factor in the beginning. Question.
Oh, that's what we need to do.
Okay.
It's magic.
All right. All right, stop. Okay. So, okay, here's what we have. We have vertical asymptotes are the next thing we check. Now, vertical asymptote, if you don't remember what that term stands for, it stands for where there's an undefined boundary where your graph cannot touch. So what you do is you look at the denominator and you figure out what makes those equal 0, because you can't divide by 0.
4 and 4.
Yeah. So you're absolutely right. So there would be 2 asymptotes. There would be a 4 and a negative 4. Those would make those denominators 0. So there, in those 2 locations, 1, 2, 3, 4, there'd be a vertical asymptote here, and there will be a vertical asymptote at positive 4. So what this is telling me on this particular graph is that there is 3 distinct pictures happening here. There's 3. The reason why, the vertical asymptotes separate your graph into 3 parts. Now I'm going to scribble on this, but I'm going to erase it here in a second. There is a graph over here, there's a graph here, and there's a graph on this side doing something. That's what it's telling me. Now, I can pretty much guarantee that either the right or left side, no matter what's happening here, it's not going to actually hit the x-axis to the left over here, so it'll either be just above or just below. So there'll be probably some curve here, or some curve down here. And same thing over here, there'll be a curve up here or a curve down here. Now the reason why is because I only had 2 x-intercepts and they're in the middle. So at some point, the outer ones will not have a graph touching the x-axis. Okay, question.
Never mind.
Okay,
You lost.
No,
So-
I figured it out. I solved it.
now, the next thing we have to do, now that we've factored all this, and the factoring, the only job of factoring is to figure out x-intercepts and to figure out any vertical asymptotes. That's all factoring does for us. The last thing we have to do is figure out y-intercepts and figure out if there's a horizontal asymptote, and that doesn't require factoring. So that's the good news,
What do we like to use?
okay? So,
Shit makes my arms look big.
okay, is everyone good so far with where we're at?
So statement of questions.
And again, if you're at home, you have questions, don't be afraid.
What?
Is that a true statement or an opinion?
All right,
That's where.
So- all right, I'm going back to the original problem now. I'm getting get rid of all these little marks. I'm going back to the original because factoring just helps with those other 2 pieces.
All right.
All right. So-
I'm gonna answer that question.
Last thing here, the last 2 parts of this problem, and then we'll try to put together a graph of what this thing is possibly doing.
So is that +4? Does that still hit the y-axis at 4? Or is that
Okay, yes.
totally different?
So yeah, so for the y-intercept, so now that's the next thing I want to talk about. How we find y-intercept. You do not factor anything apart. You are going to look at the numerator only, the numerator, and you're going to see if there is a number there that would make the top 0. Now, in our case, one of the numbers we figured out that makes the top 0 would be a 4. Now you're thinking, well, we can't use 4. No. 4 is just where it hits the y-axis. It's the number on the top. What makes the numerator equals equal when you plug in an x of 0 in. So the coordinate for an x-intercept or a y-intercept is this.
4.
And so when you plug in zeros for all the x's, the 4 would be the only number that's left. And that's where I'm hitting up here. I'm hitting 4.
Okay.
If that makes any sense. So I think I already kind of have an idea what
And
my
that's-
graph's doing.
That's just because it's a number on the end, right? That's,
Yeah.
Okay.
Yeah. So you just use the top. Now, I think I got a kind of a picture, kind of what this thing is doing. But the thing is, we still have to figure out horizontal asymptotes if it has one. So how we check horizontal asymptotes? You go back to the original problem, and you look at the largest degree on this item. What is your degree on the top? 2. And the degree on the bottom? 2, right? So for horizontal asymptotes, so this is the last check we're doing. For horizontal, if the power, the degree on the top, the degree in the numerator is equal to the degree of the denominator,
There's one curve.
there is one horizontal asymptote. So, yes.
So if the top one was 3 and the bottom one was 2, then what?
Okay, that's fine.
I don't think he's talking to you. Eric.
Okay, these are my x-intercepts. So this was -1 and -4/3. This was the y-intercept of 4. And then we had vertical asymptotes at 4 and -4. Yeah, sorry. It's a little hard to see that. Sorry, I didn't write this down. And now what we're going to do next, we've already done the vertical or the y-intercept. So now we're going to do the horizontal. So if the denominator and the numerator have the same degree, so in this case that does happen, right? They have the exact same degree on this particular problem. That means your horizontal asymptote, since the numerator and the denominator equal each other in power, you take the leading number out front of each item. So the leading number up here and the leading number down here, and you divide them.
1,
I'm
3.
not doing what I'm talking about.
That number is where the horizontal asymptote will be found. If the powers are the same. If the powers differ, then that's what we're going to look at tomorrow.
So there's a dash line going.
So there is a dashed line going through the number 3. Now, you're thinking, well, you just told me it's a horizontal and I have some dots down here and some dots up here. The horizontal is a guideline. It's not like the vertical. Vertical asymptotes are super rigid. Nothing can cross them. But horizontal are like a little bit flexible. It's a guideline where the lines are going to be found. So, here's what I'm thinking. And this, again, I'm guessing. That's where this comes down to just a pure guess. I'm guessing, since I don't have any X-intercepts here, right, on the other side of this vertical, I'm guessing there is no graph down here. Because if the graph was in this area, it would cross the X-axis somewhere. So I'm guessing my graph's up here somewhere, doing something like this, where it's not even touching the X-axis, it's kind of floating up in the middle of nowhere. So if you're at home, here you go.
What is the 3 divided by 1?
Dude, that's
It's something like that.
GoPros are touchscreen?
Okay, yeah.
And it's the same thing on the other side too?
Yeah, and I'm thinking the same thing over here is that it's not hitting the X-axis on that right side, so it's probably up there right above the horizontal and right next to that vertical asymptote.
So why are they there?
It's as a guideline because those two tails right here are going to come down and they're going to hug up against it.
Right.
So it's telling me like where the end
touch
behavior
both
will be.
asymptotes.
Yep. Yep.
So I don't get the 3. I know the 3/1 is because in the example it's
Yes.
3/1.
Yes.
What do you mean? What does that have to do with anything?
That's where the horizontal is going to be found. It's going to be found at 3
What-
So if it was 6/3, it'd be 2.
Yes.
Is it clicking there?
Okay. That makes
What are
sense.
the point
That
of,
makes
what's the point of
sense.
the dots we made then?
The dots. The dots for the X-intercepts and Y-intercepts. Now I'm going to draw where the middle is. What I'm thinking the middle's doing. Okay? Question.
So are there 2 graphs in the middle?
There is one graph in the middle,
Oh.
and it's just happening to be crossing that horizontal asymptote. I'm thinking, and this is a mere guess, I'm thinking that the middle is probably doing something like this. It's probably doing something like that. Now, again, this is a guess. I mean, it could be down here and kind of looping its way up through, but I'm just guessing because everything's like an even power. X squared is X squared.
So
I'm kind of
it's
thinking,
going up.
yeah. Question.
Well, I didn't
So
do
why
anything with
know
that.
that there's nothing in the bottom left corner?
Okay.
The bottom left, because when you looked at what our X-intercepts were earlier, we only had 2, right? We had the -1 and the negative. There was nothing over here. And so if I were to draw a graph over here, it has to hug up against this, right? On the outsides? Well, it would have had to cross the X-axis, so I'm betting it's probably above.
So let's say this was moved, it was all moved down.
It'd probably on the
Moved
bottom. It'd probably on the bottom, yeah. So if you didn't hear Jamie's question, it was excellent. If the horizontal was shifted down further, the graph probably would have been down here instead.
So the Y asymptote or whatever is pretty
Jamie,
important.
I use
Yeah,
your sewing
super
machine
important.
to sew
Kind of tell me where it's
this.
going.
Right.
Yeah.
Well,
For,
Yeah.
Did you see my bag?
Question.
So the horizontal asymptote is just
I didn't-
influences the
I didn't do
side.
anything.
It really influences where the end tails are going, the outside tails. That's really what it's telling me. It's not a rigid. It's not like I can never cross it. It's just kind of telling me where I'm going to hug up against.
So only the vertical is rigid, like.
Yeah, the vertical are super rigid. Nothing can cross the vertical. A horizontal is more of like a guideline. Where do the outside tails need to go? And it kind of helps me narrow down where it's going to be anyway. Question.
So if it was negative, those outside tail ends would be on the bottom.
So yeah, so if this was like a -3 instead, you're absolutely right. These things here probably would have been down here instead, because I don't want to cross the X-axis.
Because then
So,
we know the
because
point.
if this bar was shifted down, I have to hug up against it, so it'd have to be down here because I don't want to touch the X-axis
And
ever.
so there wouldn't be anyone on the top.
Probably not.
Yeah.
In theory.
It has to hit the X-axis. yeah.
If you have more than one horizontal asymptote, would
There'd only be one. There's only one.
there's always only one? Oh.
Where'd you get that back?
All right, questions. These are good questions you guys are asking.
There's something.
Okay. Now, I was gonna do 2, I'm only gonna do 1 problem today.
Good
The
call.
reason
Great
being,
call.
I do wanna give you time to work in your homework, and you don't have a lot of time.
You got
I'll give
tape?
you about 10 minutes to do it, okay? It's not due until Friday. So for those tuning in at home, sorry, if you guys wanna type this in Google, or Wolfram Alpha, or Desmos, you can kinda see what the graph is. I'm guessing it looks like that, I could be wrong. This is a guess, it's a guideline. I'm using all the rules that I know to get as close to the accurate graph as that it can. Okay, and that's what we're going to be looking at tomorrow. We're going to do more rules. We have other things to look at, especially there's more rules for horizontals. So we'll look at those rules tomorrow. But hopefully this made sense as like a first introduction day. Okay? All right, thanks for tuning in. I'll keep sending out the links every day. The videos are working on the website, so you can watch those. Homework's due on Friday. That's your worksheet. 1.5 part 3. I think I emailed it out to everybody. So Hackler, hopefully you received it yesterday. So you can put it on a little piece of paper and just take a picture.
Tell them to like, subscribe, and comment.
Like, subscribe, comment down below. How about that? Yeah, just do that. My son says that. That's how much he watches. So, but yeah, yes, Hackman, I just take a picture of your phone. All right.
Throw one up there for tables, another one.
Yeah, I'll put up another one. I'm gonna keep going. I'm not gonna turn off the. If somebody wants another one, so I'll just throw one up for giggles here.
Do you have tape?
Why do you need this?
Yeah, I'm just taping on my desk.
You know what?
We already had taken it off your desk.
Okay.
I don't know.
All right, let's start with another one here.
Why do you have?
Okay.
Jared,
What's
the period length?
just
Why you
giggles.
always crying?
Okay.
Why you always
So,
crying?
a certain thing that you want in there, Heitland, is a certain type that you want. You want something that's very similar to that?
Yeah.
Okay.
Or if you do anything different, is it?
Can I have my jorts back?
Yeah, they're in my room.
Okay, I'll just go get my
Just
So-
whatever you want.
Okay, let's go with like x cubed plus 64. And on the bottom, let's go with x squared plus 9x plus 10. Or let's go minus 10, sorry, minus 10. Let's do that.
More used to Janet's shower.
That's who's always in there.
Oh, more.
Now this one's a little bit different, right? Because I'm just changing up some different rules. There's rules we're gonna talk about tomorrow for like how do you do like horizontal asymptotes differently and stuff. So that's the stuff we're gonna like hammer down tomorrow.
So
I was
the
trying to ask
top,
her through
is
the
that
camera,
still the
but-
vertical?
That is still, the top is still X-Intercepts, and we'd still use it for Y, Y-Intercept.
And then if the teacher says something.
And then the bottom will be vertical asymptotes.
So
So,
it never changes, like the top is always gonna
Believe it or
be.
not, I'm
X-Intercept, Y-Intercept, yep, yep. They're always the same rules for that.
Yeah.
So, yeah, so on this one, it looks like I'm gonna hit a Y-intercept on this problem.
Yeah.
A Y-in of 64. So that's way up there. So this is, I'm gonna just say this dot is 64. That's way up there, okay? I'm just gonna put it there, it doesn't matter. Okay? All right. Now, X-intercepts, I have to factor. How you factor this monster apart, it is a cube rule.
Is it 4?
So, yep, it's gonna be X plus 4. That is the cube of each of those. Now remember, on cube rule, it's a binomial and a trinomial. So it's a binomial and a trinomial. So then, yeah, so then the next part is that this symbol will be opposite, and then it'll be the plus in the back. And then what you do is you square these items. So you square the X, so that's X squared. You square the 4, that's 16. And for the middle, you multiply these two together. So this will be 4x. Okay, this will not be able to factor apart again. You won't be able to do it. You can check to see if there's any X-intercepts by doing a quadratic formula and whatnot. It usually turns out to be an imaginary number, so there's no X-intercepts there. But this one does have one X-intercept. What is it?
No, -4.
-4. That's your one X-intercept that you have. So -4 is an X-intercept.
We got me a little
That's where I
pocket.
start. And then you
That's the one person who started it.
So a really small box, sorry. There's a -4. Oh, that green is not showing.
It's like nothing then.
Brandon.
Okay.
I mean,
if you mind, okay, so now, we have to do what? Vertical asymptotes and horizontal?
Why are you asking?
Okay, so for vertical asymptotes, we have to factor the bottom.
What did you get for your space?
So, what do you get when you factor the bottom?
All of them?
For number 5.
Number 5. I got,
I had
It'd be-
-4, 5, or 2, and then like the
Plus
plus.
and minus and plus.
Yeah, it'd be plus minus automatically, doesn't matter. If you want minus plus,
I
same
got to
thing.
here, and I'm like,
X
do
and
I
X.
divide it by.
And now we gotta bring up to 10. Probably
Not 5, 2.
10 and 1. That makes 9 in the middle.
For like this part.
And so it looks like I have 2 vertical asymptotes. I have one at +1. So there is a vertical asymptote at +1.
That's the first one.
And then there is one at -10.
And then I.
Because I'd set each of those equal to 0. And so those would be my verticals. So -10 would be this one. So this picture has 3 pictures going on. It does have 3 pictures again.
the reciprocal of it?
Now, the weird part is, this problem doesn't have a horizontal asymptote. What gives it away that it doesn't?
Because they're not the same.
Yeah, they're not the same power for your highest degree, not like the last one. The last one, when the powers match, you just divide the two numbers. Since this one has the higher degree on the top, you wouldn't have a horizontal. Okay? Say it again. Then you would have a horizontal at 0. And that's the rules we're going to talk about tomorrow. This one, though, has an asymptote, but it's not quite horizontal. It's slanted. It's the slope between them. So how you need to do this, and this is the weirdest thing in the world, this is something we're going to look at tomorrow. You have to actually divide these two things from each other.
And then just, you don't have it.
So you have to divide them like synthetic divider, long divider. And then what's left would be the actual like slope of the asymptote line. It's actually a slant asymptote. And so that's what we're looking at tomorrow. And so this thing could be slanted something like this. You know, it could be like at a diagonal or down like that, and we're going to look at it tomorrow. So it's going to be positive. So I'm not going to do it now. I'll wait for tomorrow. But let's say it looked something like this. Let's say it looked like that, right? So that means my graph will be up here. It'll be up here. And then this one's probably going through the middle. So maybe it's doing something like this.
You're gonna go by 3.
It's probably doing something like that.
Appears like pi. So if you
What's up? It could be at the end of the week, or it could be the week after. We still got 2 sections left. Yeah. So this will be like, we're just introing this stuff today. So like the next couple days we're gonna work on this stuff, and then next week we'll do the last section, and then we'll start reviewing 2-day review, and we'll take the test. So that it could be the end of next week, or it could be the week after that. So we got some time.
And then you add.
We can do it online, so I can just Zoom you and you can just answer questions on like a little piece of paper. So if you want to do that, you want to do that maybe tomorrow or Friday? Yeah, I'll Zoom you. We'll just set it up for like after school. I'll Zoom you, I'll ask you a question, I'll hold it up on camera for you. Actually, I'll just share my screen. And then you'll just answer on a little piece of paper on camera right in front of me, so I can see your hands and I can see your writing. And then what you'll do is at the very end of the test, after we're through every question, I'll have you on camera take a picture of it with your cell phone, like live on camera. And then you're going to email it to me and stay on camera while you email it to me. When I get it, then you can hang up. Does that make sense? I've done it before. It works for every kid that's tried it so far. So, if that works for you. So.
There's 2 subjects.
Lord,
Yeah.
how do I do this?
Okay, I'm going to turn off the camera now. Set up a time with me, Hacknoy, that you want to take it, so we can get you to go. And then, Erica, don't worry, we got a lot of time. We're just introing this stuff today, so
It gives
okay.
you 2 parts.
All right. Okay.
Oh, really?
I'm going to turn off the camera here. Thanks for tuning in, guys. Keep doing it every day if you're going to be out. And then I'll set up a private Zoom if you guys need more help.
Cool,
So
that's it. I'm telling you.
hopefully you feel better.
You are forward.
Isaac, we're gonna get into it. What?
Nothing relevant, don't worry about it, you don't wanna know.
Rudolph,
Word for
You don't
Sorry, I'm coming. I got a bunch of stuff I got to do.
I got that
Also,
email already.
I don't know how you're familiar.
Okay,
Are you in the same
Captain, do you want to
class?
see any topic forwarded to you?
Okay,
No.
so.
Do you want to read through this?
Okay,
today?
I don't.
You're going to start point, so you multiply.
Oh, is it 2,
I will
3,
block
and then
you.
you flip it?
No, just put the
You
thing above.
you can try and block
So
the
6,
schooling
yeah.
with your schooling.
Oh,
That's just
well,
okay,
easier
just put
than
it
I
I'll
thought.
tell parents about it.
Oh.
Technically, what you're saying with the reciprocal is correct, but it would be 3 over 1 on the
You
bottom.
can't
And then you have to do a
Isaac,
flip.
how fun would it be if I got to do like 4x4? I just get to go.
Exactly.
Now, Eric, if you want to see me actually divide that so you can see what it's talking about,
So fun.
I want to do this on camera. It's just kind of ugly. They never would see it. All right.
I know how to
You had a good
my
day.
mind state refresher.
Can't do that in golf.
I don't remember synthetic
Dude,
divide.
I kind of want to do golf.
Not synthetic dividing.
Wait, is that right?
So
Golf would be fun, but at least we have a better.
Okay, 1 times x gives me x cubed. Well, it would be an x,
Not
right?
carry
So
the
it's x
making fun
cubed
of
plus
stuff.
9x
Are you
squared
looking?
minus 20. I switch to signs.
More of a chance you did not clear up.
Negative, negative, positive, add straight down.
I think they do function.
Your room's already.
Chance that you draw a pair.
Yes.
And now I'll have to multiply by negative 9, right? And this, right there, that's my equation.
What is that
So
for?
that would represent my slant line. So my slant line was way off. It is going up 1, but it would actually be down here. It's hitting negative 9,
But it's a one.
and it's a 1-to-1. So this is where that slant's going through. So it looks like my graph was up here then. Probably something like that.
Why is this the correct one for OC pen?
Yeah.
Hey, Eric.
Yeah,
How much do you
this is
miss
just
for
intro
golf?
today.
What? How much like school do you miss for golf?
Pressure cans now.
Not much.
Occasionally, you'll miss, actually, whenever you have a meet, you normally miss 9 periods, so whatever your classes.
This project.
Spanish?
Yeah, also, sometimes you miss full days,